That's section 7.5 in chapter 7. I'm talking about inverse circular functions. So that's like inverse sine, inverse cosine, inverse tangent, inverse cosecant, inverse secant, and inverse cotangent. So first we want to talk about being a one-to-one function, and you can recall from being a one-to-one function that means for every x, there is one y, and also for every y there is one x. So example, if I have 1, 2, 3, 4, I'm in my domain, right, and they get mapped to my range, my y's, my x's and my y's, A, B, C, D. That means everything in my domain has to go somewhere. Okay, so everything in my domain has to go somewhere. There can't. So everything has to go somewhere, and then it has to go only to one spot. Okay, so here this 2 went to B and this 3 went to B, and say D goes to C. Okay, so this would be a function because every single one of my domain goes only to one spot. Okay, but it would not be a one-to-one function because my y, all my y's, don't go to 1x, because this b right here goes to two different numbers, so that would not be a one-to-one function. It is a function, but it is not one-to-one. So if the 2 went to, say, 3 and the 2 went to C and the 3 went to B and then 4 went to D, that's fine. Basically there's one arrow coming out of the blue numbers here and one arrow coming from the green, so we're fine. So this is a one-to-one function. Okay, also remember that if a function is one-to-one, so if a function is one-to-one, that means its inverse, one-to-one, then its inverse is a function. Okay, so that means that, say, let's do f of x cubed. So this is one-to-one, right? For every x, there's one y. If we do the inverse would be the cube root of x. That is also a function, right? So this is a one-to-one function. That means this is a function, which is true. Okay, so an inverse function, we read f inverse. This is read f inverse. So this right here is read f inverse, or the inverse of f. Okay, so if I have some function f, okay, for instance, we can do the 1, 2, 3, and 4, and then we have, in this function's one-to-one, okay, so that we did that before, right? We had A, B, C, D, 1, something like this, right? Okay, so my inverse would be going backwards, right? So f and f inverse would be going backwards. So actually, this wouldn't be f there. F would be the function that gets you there. This would be your domain, and this would be your range. Well, if I find the inverse, f inverse would be the domain would be A, B, C, D, because I'm going backwards, and I'm going to 1, 2, 3, 4. So 1 would go to A, B would go to 3, C would go to 2, and D would go to 4. So it's going backwards. So notice that my domain of f is the range of the inverse, right? Is the range of the inverse. And my domain of the inverse was the range of f, right? So the domain or the range became the domain, and the domain became the range, because they're they're switching, right? And that, which gets us back to, how do you find inverses? So you can remember this from last semester when we talked about finding inverses. So remember this, how we find the inverse. We switch f of x to y if we don't have y in our equation already, and then we swap our x's and y's, they exchange places, and then third we solve for y, and then I guess fourth you could just say that we change y for f inverse, right? So we switch that back. Okay, so here's an example. So we could do this two different ways. We could multiply everything by 2 to get rid of that 1/2 first, or we could add 3 first. Okay, but first we're going to switch that to y, like we said in step 1. And we're going to switch our x's and y's. So this is going to become x, this is going to become y, and then we're going to solve. So now how to solve this one is we can multiply everything by 2 to get rid of that, or we can add 3 first and then multiply by 2. But so we can go ahead and multiply by 2, so that changed this just y squared, and then minus 6 here. That's what you got to kind of be careful of when you have that a number in front of the that y. You got to multiply or divide depending on what that number is, right? This was a fraction, so if we multiply, that gets rid of that. Oh yeah, then we add 6, so I get 2x plus 6 equals y squared. You can get rid of the squared by square rooting. And so there's our answer, and then we can switch that y to f inverse of x. And so that's how you solve for the inverse. Okay, so the sine function, sine inverse of x, it can also mean arc sine. So arc sine and sine inverse mean the same thing. And then what happens when we graph normal sine? So when I graph normal sine, it looks something like this, right? We have negative pi halves, we have 0, we have pi halves, we have pi, we have 3 halves pi, and we have 2 pi, right? And our graph starts at 0, so that means negative pi halves would be negative 1, and then it goes up to 1, it goes back to 0, and then it goes down to negative 1. Oops, messed up there. Drop that right there, drop that right there, and then back to 0, right? So it would look something like this. And then it keeps on going, right? It keeps on going up. That's why it keeps on going down here to negative 1. Well, in order for this sine function to be 1 to 1, we got to restrict its domain, right? So we got to restrict this domain. And so that's why we have this restriction right here from negative pi halves to pi halves. So if I restrict this, basically meaning that I'm just going to delete here on, I'm just going to delete that. So now it's 1 to 1, right? Another way to do 1 to 1 is the vertical and horizontal line test. So this would pass the horizontal and vertical line test. So basically I'm eliminating this. And now we want to find the inverse, which means I switch my x and y and I solve for y. So here, like right here, we switch x and y, right? So they swap places. And then we go ahead and solve for y, and that's where you have this inverse thing. So then you have your inverse, so we're finding, excuse me, y equals sine inverse of x. Okay, and so our answer has to be somewhere between negative pi halves and pi halves. And what does these x's represent? Well, those represent our angles, right? Sine of an angle equals something. Well, here our graph is now going to be, our x's are now going to be our y's, and our y's, which are our x's, which were the angle, are now going to become our y's. So we go from negative pi halves to pi halves. So our x's became our y's, and our y's became our x's. Now we can go ahead and graph this. And that's kind of spread out there. Let's kind of eliminate that. Let's make it a little bit more even. 1. Okay. So it just looks like a cubic. It just turns that sideways. That probably wasn't the best. Oh, that's ugly. Okay, there's a better looking graph. Okay, and so why we do that is just to show that, hey, in order to do sine inverse, you know, we basically switch your x's and y's, which means for these type of problems we are actually finding the angle, right? Before we were just plugging in the angle and finding the answer, right? The ratio between, for sine it was opposite over hypotenuse on a right triangle, right? So now we are having that ratio, that fraction of opposite hypotenuse on a triangle, and finding what angle produces that, right? So you can use the left-hand method still, but here you're trying to figure out what finger do I need to put down in order to get sine of something. So let's do a couple examples. So here we have finding the arc sine of 1/2, and that means the same as sine inverse of 1/2. So basically here are the questions, right? Sine of what angle gives an answer of 1/2? So going backwards, if I switch my x and y's, it becomes 1/2 equals sine of what? So sine of x. So what gives us a sine? Sine of what gives us an answer of 1/2? So which finger do I have to put down on my left hand that would give me a sine of 1/2? Well, that is 30 degrees, right? It's putting down that second finger there. So 30 degrees, or you can put it in radians as pi6, right? So either of these two will work. What gives us sine of -1/2? Because we can't do, so also what would give us 1/2 would be 150 degrees. So 150 degrees, but we are between, right? Our domain is restricted between negative pi halves and pi halves, correct? So that's why I couldn't do the 150 or the 5 pi 6. Okay, so this one that's -1 here, don't think about this -1. What angle gives us an answer of basically 1? So what finger do I have to put down in order to get an answer of 1? Well, that would be 90 degrees, right? So that is 90 degrees, but I'm restricted between -90 and 90, right? Negative pi halves and pi halves. So I need a -1. Well, that's down below, right? Sine is the y value, basically. So that's down below, so that's kind of 270, right? So that's more like 270, but 270 is not between negative pi halves and pi halves. 270 is actually -90, right? That's what negative pi halves is. So it's one of these two, because 270 is the same as -90 and negative pi halves. I have to do this one because this is where I'm in between, right? Okay, what gives an angle of -2? So if we look at sine function, here sine function looks something like this, right? What's the height? Do we ever get down to -2? Do we ever get a -2 here on sine? No, the lowest we can go is -1. So this is not possible, right? Or does not exist. Okay, so it does not exist. There is no angle that's going to give us a sine of -2, an answer of -2. Okay, so here's 3 problems practicing on the inverse sine. So remember, basically this graph is just finding what angle gives us these answers, right? So if we look at number 13, we're looking at y equals sine inverse of 0. So basically, what is the angle that gives an answer? So sine of what angle gives an answer of 0? Well, that is 0 degrees or 0 radians. So that's number 13, right? And then number 21. So 21. And you can pretty much just practice these. So this is pretty much going backwards. Arc sine, remember arc sine is just sine inverse as well. Arc sine of -√3/2. So don't worry about the √3/2 though. To begin with, we'll figure out that. But what gives us a √3/2? What finger do you have to put down that on the right hand side? You got 3 fingers sticking out on the right side of your left hand. And so that would be a 60-degree angle, right? So that's a 60-degree angle, but we're between negative pi halves and pi halves, which basically is in these 2 quadrants, right? First and third, but we need a negative, so that means we need to be below. We need to be down here. So that means we're really going to look at a -60, right? So if we go negative 60, that's going to get us that. So -60 degrees or negative pi thirds, right? So that would get us that one. And then number 25. So looking at number 25. So if we look at this one, y equals sine inverse of √3. So what finger can I put down that I get 3 out? 60 give me a root 3 over 2, right? So there's no just plain root 3, right? Because root 3 is almost square root 4, and square root 4 is 2, so it's a little less than 2, and the square root of 1 is 1, so square root of 3 is in between here, and my highest answer can only be 1, right? So this does not exist. So that does not exist. Alright, so that's it for the sine. In the next video I'll do cosine.